Good morning, 8th grade. I hope you are well and that you had a relaxing and enjoyable Easter weekend. Before we get to today's lesson, I want to point out a few things. Number one, I have graded the OneNote homework from last Monday and last Tuesday, and I want to clarify something. This said Monday and Tuesday because the Monday assignment was to answer the volume problems, and the Tuesday assignment was to answer the surface area problems. I apologize if that was unclear. I tried to make it clear in the video that accompanied them. So if you only did the volume or only did the surface area, go ahead and go back and do the one you haven't done yet, and I'll figure out how to give you full credit for your work. Number two, so that you can get some information on things you may have missed, I have included in your homework folder, it should say, I don't know what it says, there we go, Monday answers. These are the correct answers from last Monday's work, the volume problems for prisms, and then I've also uploaded the surface area answers for the prism worksheet. You can compare your answers to those correct answers, see what you may have missed if you missed anything, and if you have any questions about it, feel free to email me or jump in on my Zoom office hours, which I will be doing today at 1 o'clock. Okay, let's go to today's lesson. Last week we talked about prisms and we talked about cylinders. Today I want to talk about the volume of cones. The reason I want to jump to the volume of cones is because it is very specifically related to the volume of cylinders. I will be including in your packet on OneNote for today a YouTube video demonstrating the relationship between cones and cylinders and also between pyramids and prisms. The idea here is that a cone is always exactly 1/3 the volume of a cylinder with identical dimensions. So if you had a cylinder, for example, let's look at number 2. If you had a cylinder that was a radius of 4 and a height of 12, the cone that has those same measurements will have exactly 1/3 the volume of that same cylinder. Because we're dealing with a shape that has a circular base, so cylinders have a circular base, cones also have a circular base down here. The first thing we're going to do, always, if we see a circular base, is we're going to find the area of that circle. And the formula for the area of a circle is pi r squared. So if you see a three-dimensional object with a circular base, whether it's a cone or a cylinder, always just start off by writing down pi r squared, because that is going to come up in your formula somewhere. And if we think back to what our formula was for cylinders last week, we did pi r squared, the area of the circle, and then we multiplied that answer by the height of the cylinder. So, for example, in number 2, we know that we have a radius of 4. The radius is from the center of the circle to the edge. And we have a height of 12. That's from the floor all the way up to the top. If this were a cylinder, this would be the end of our formula. The area of the circle multiplied by the height, pi r squared times h. But since this is a pyramid, not a pyramid, a cone, and a cone is always 1/3 the volume of an identical cylinder, we're going to take the formula we know for a cylinder and we're going to divide it by 3. Then we can substitute in the information we know. So pi times our radius squared. What's our radius here? It's 4. So we're going to put down 4 squared. And we got to multiply that by the height. Our height is 12. Multiply that by 12. All right, what is that going to equal? Let's pull up the old calculator. Remember, if you don't have a calculator at home, there should be one like this built into your laptop. There are also scientific calculators online that you can find through Google. So let's do 3.1, why is it? There we go, 3.14 for pi times 4 to the second power, we know that's 16, times 12. That's 602.88. And if this were a cylinder, that's where we would stop. The volume of a cylinder with a radius of 4 and a height of 12 would be 602.88 millimeters cubed. But this is a cone. And a cone is always 1/3 the volume of the identical cylinder. So there's the answer to that problem, but we have one more step. Because it's a cone and it's 1/3 the volume, we have to divide by 3. So let's divide that by 3. 200.96. So the volume of this cone is 200.96. And volume is always the measurement, in this case millimeters, cubed. So take the radius, square it, multiply it by pi, multiply it by the height, take that answer, divide it by 3. What if Mr. Hale's trying to be sneaky, and instead of giving you a radius from the center to the edge, I've given you a diameter all the way across? Well, we have to remember that a diameter is two radiuses put together. You have a radius here, and you have a radius here. Both go from the center to the edge. So a diameter is just the radius multiplied by 2. If we know the diameter is 3, then the radius is going to be half of that. Because the radius is just going to be, hold on, let me grab the eraser, is just going to be this half of the diameter. So the radius on number 1 here is half of 3. It's 1.5. Once we know that, it's just a matter of plugging things into our formula. Remember, it's pi times the radius squared times the height. That would be the volume of a cylinder. We're dealing with a cone. Divide by 3. Let's plug that in. So we've got pi times, this is one I don't know off the top of my head, 1.5 squared times our height. Our height here is 10. Little sloppy writing with a mouse. And then since we're dealing with a cone, we divide by 3. All right, let's plug that into the calculator. Here's how we're going to do this. We're going to do parentheses 3.14 times 1.5 squared times 10. Close our parentheses. So if this was a cylinder, our volume would be 70.65. We're dealing with a cone, so we got to divide by 3. That's 23.55. So the volume of this cone is around 23.5 centimeters, and since it's volume, it's always centimeters cubed. All right, let's do one more example because the formula doesn't change. And this is a fairly simple setup. If we know the radius, we know the height, it's all we need to know. Then it's just a matter of plugging it into the formula. So, number 3 here, we have a radius of 6, and we know it's the radius because it goes from the center to the edge. And we have a height of 14. So let's plug that into our formula. We're going to do pi times 6 squared, because 6 is the radius, and our height is 14. If that we were dealing with a cylinder, that would be the end of our formula, but we're not. We're dealing with a cone, and a cone is always 1/3 the volume of a cylinder, so we divide by 3. Let's grab that calculator again. We're going to do 3.14 times 6 squared. We know that one off the top of our head. That's 36 times 14. If this were a cylinder, the volume would be this, 1,582.5. But we're dealing with a cone, so we have to divide by 3. And that gives us 527, my calculator went away, 0.52. This one is measured in yards, and since it's volume, we put it to the third power. So your cone formula is just your cylinder formula divided by 3. Pi times radius squared, that gives you the area of the circle on the bottom. Multiply that by your height, and then since this is a cone, we divide by 3. The problems that you have for your homework today are the volume of 6 cones. I have taken this exact same worksheet and just changed the numbers around. I've also tried to make things a little easier to follow. There's now a week of April 14th folder, and then you'll see that Tuesday, April 14th has this worksheet, but it only says volume here. Then Wednesday, April 15th, tomorrow, is the same worksheet, but it says surface area. So I hope that's a little clearer what you're supposed to do which days this week. If you have any questions, feel free to email me. I'll also be on Zoom for office hours this afternoon from 1 to 2:30. Wash your hands, stay home, do your best, and I hope I get to see you guys soon. Bye.